We're live with example A from section 9.3. Are you ready? I said, are you ready?
I was born ready.
Okay. Consider the sequence 2, 6, 18, 53. Everybody consider it. Okay, you've considered it? Is it geometric?
Yes, sir.
Is R what? What is R?
3.
Okay, it's growing by 3. When they say find U15, do they want the address of the house that's the 15th house on the block? Or do they want all those addresses added up? Oh, that would be the sum. And it would say find S15. When they say find U15, they want the 15th house. And geometric goes a little something like this. UN equals. Do you like the one that starts with U0 and then has R to the N? Or U1 times R to the N minus 1? You like U1? Okay. So the formula goes U1 times R to the N minus 1. If you don't like this way of saying it, you could do the problem with UN U0 times R to the N. Not to confuse you, but I might do both. Okay? Watch how this would work. Are you ready? So if you wanted U15, you would need the first term, which is what? 2 times, what's R? 3 to the N minus 1. And you would let N equal 15. So it would be 3 to the 14th power. If another student was doing this problem using U0, the first thing they would need to do is figure out what house would live back here. 2/3, because moving forward in this sequence, you're multiplying by 3. If you go backwards in the sequence, you're dividing by 3. And what's 2 divided by 3? 0.6 repeating, or 2/3. So another student might find U15 this way. U0 times R to the nth. And they would just plug in not 15 minus 1, just 15. I'm just confirming that both of these formulas would give us the same thing. I think they will. This one is multiplying 2 times 3. How many times? 14 times. While the other formula is multiplying 2/3 times 3, 15 times. Well, that's okay. Once it multiplies 2/3 times 3 the first time, what's 2/3 times 3? 2. Then it has to multiply by 3 how many more times? 14. So it's the same thing. It's going to give us the same answer. So again, you do not have to do both of these columns that I'm doing. Pick your favorite. 2/3 times 3 to the 15th. Either way you slice it, what do you get? Thank you. Thank you, student. 9,565,938 is the 15th term. We're not going to do this part. I'm not going to require you to graph the partial sums. If you did, you made a graph out of this, sum 1 would be here, sum 2 would be here, sum 3 would be here, here, and then all of a sudden it would be like, woo, right? If you're adding up all the terms, this thing's going to just grow exponentially. Okay? So we're not going to bother with that, but we are going to find sum 15. They asked us to do that right here. That uses our new formula. Our new formula from the front of your packet. Yep. And that formula goes a little something like this. The sum of n terms is, I like writing it like this. It's just like the old formula, if I had to memorize it. I would start with the old formula, and then this bottom shows up again with what here? An exponent. We'll call it n, the nth power. Okay? Yes, but you're not allowed to cancel anything in this formula. So the sum of 15 terms would be, what was the first term? 1 minus 3 is r to the how many terms? It's all over 1 minus r. I suggest you do this. It's 2 divided by negative 2, negative 1, times what's 1 minus 3 to the 15th. Just type this in. Negative 1, parentheses, 1 minus 3 to the 15th. You're going to get a big number. It might be in scientific notation. It's not. No, it's not going to be negative. 14 million. That's the sum of the first 15 terms. So on your graph, if we were trying to graph this, you would need a piece of graph paper that had 14 million grid lines on the y-axis. Yeah, you use a really big scale. All right? So that's the partial sum of a geometric series. Again, r does not have to be a decimal between negative 1 and 1. It's allowed to be anything. And that's it. Example A, done.